or more than 5 times, 5 times or more than 5 times of 343 meter per second. Clear? This is what hypersonic. At such speeds, aerodynamic heating becomes a significant factor due to the compression of air in front of the object. This presents significant engineering challenges for vehicles designed to operate at hypersonic speeds, including missiles, aircraft, and potentially space vehicles. So basically, like missiles, aircraft, and potentially space vehicles are the examples of hypersonic objects. Okay, clear. Moving to next question. Again, a simple theory question. What is quantum physics? Okay, nothing much. Quantum physics is basically a branch of physics. Quantum physics is a branch of physics that studies the behavior of subatomic particles such as electrons and photons at the most fundamental level. Unlike classical physics, like which describes the macroscopic world, like mechanics and all, unlike classical physics, which describes the macroscopic world, quantum physics is based on principles like superposition and entanglement, allowing particles to exist in multiple states simultaneously. Wave nature, particle nature. Okay, we have studied in dual nature of matter. So, as for now, simply quantum physics is a branch of physics that studies the behavior of subatomic particle. Clear? Okay. Nothing significant in MCQ questions. So let's move to question number 3. Kepler's law of planetary motion. Okay. Kepler gave us 3 laws of planetary motion. Okay. 3 laws. The first one is Kepler's first law. What is Kepler's first law says? Kepler's first law, also known as law of orbit. Kepler's first law, also known as law of orbit. It basically says every planet revolves around the sun in an elliptical orbit with the sun at one of its foci. That means, see, suppose this is the planet. This is the planet. Planet revolves around. Every planet revolves around the sun. Around the sun. This is sun. Around the sun in an elliptical orbit. In an elliptical orbit, not a circle. In an elliptical orbit with the sun at one of its foci. The position of sun is one of the foci of ellipse. Either it should be here or here. Clear? Okay. And the ellipse go to 2 axes, minor axis and major axis. Here major axis is length of major axis is 2a and the length of minor axis is 2b. Clear? Okay, this is what? Kepler's first law. Moving to Kepler's second law. Kepler's second law. Kepler's second law is known as law of area. Law of area. Basically, its definition goes as the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. Basically saying, or simply saying, I can say Kepler's second law is, that is Kepler's second law for MCQ solving. Yeah, we have to remember this equation is equation dA divided by dt is equal to L by 2m. This is equal to actually constant. Basically saying the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. So if I want to demonstrate diagrammatically, see, this is the ellipse. Suppose this is the ellipse. This is the ellipse. And sun should be at one of the foci of ellipse, right? One of the focus of ellipse. So sun is here, sun is here. Okay, sun is here. And suppose planet first move from A to B. From A to B. Okay, in second instance, the planet moves from A dash to B dash. So we have to make an area here. How? See, the first condition, this is the area, and second condition, this is the area. Clear? So this area, see, the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. That means area divided by time ratio. Area by time should be a constant, and that constant is equal to L divided by 2m. L divided by 2m. Clear? Or we can also say aerial velocity of the planet. Aerial velocity of the planet is constant. This is what basically Kepler's second law says. Okay. Moving to Kepler's third law. Okay. MCQs can be make from Kepler's second law because it contains mathematics. So next, Kepler's third law. Kepler's third law is basically law of period. Law of period. It says the square of the time period of revolution of the planet around the sun is proportional to the cube of the semi-major axis of the elliptical orbit. Okay, I have told you what is semi-major axis. What is major axis? Yeah, this is what major axis 2a. Okay. So in Kepler's third law, the square of the time period of revolution of the planet around the sun is proportional to the cube of the semi-major axis of the elliptical orbit. Basically, it is t square directly proportional to a cube, where a is semi-major axis, or half of major axis. Clear? Okay. Lot of MCQs can be made from Kepler's third law by relating time and semi-major axis. So it's very important. Square of the time period of revolution of the planet around the sun is proportional to the cube of the semi-major axis of the elliptical orbit. Clear? Okay. Yes. So moving to fourth question. The fourth question asked is, what is average speed? It's again a basic from motion in a straight line chapter. Average speed means, what is average speed? Average speed is very simple. Make it simple. It's the total distance. It's the ratio of total distance divided by total time interval. Total time interval. Whereas average velocity will be total displacement divided by total time interval. Simple. Average speed is total distance divided by total time interval. Okay. So I have a question from average speed. So first, if we solve this, the concept of average speed will be clear. Okay. So the question says a body moving in a straight line travels the first half distance at v1 and the second half distance at v2. What is the average speed for the whole journey? So basically saying a body moving in a straight line travels the first half distance at v1 and the second half distance at v2. So suppose body moves from A to B. Body moves from A to B. It's a straight line. Okay. It's a straight line. Body moves from A to B. Okay. First half distance. The first half distance velocity of the speed of the body, speed of the moving body is V1. And the second half is V2. You have to find out what is the average speed for the whole journey. So what is the equation of average speed? Average speed, I can write average speed is equal to total distance. Average speed is equal to total distance divided by total time. Total distance divided by total time. So here, what is the total distance? Suppose let me take from A to B. This midpoint I am marking as O. From A to O, distance is X. So O to B will be also X because AO is half of AB. Clear? Okay. So XX. So the total distance here will be X plus X. Total time. So here we know the speed. So total time will be from A to O. The time taken will be how much we know. Speed is equal to distance divided by time. Speed is equal to distance divided by time. Speed is equal to distance divided by time. So time will be, just rearrange the equation. Time will be distance divided by speed. Clear? Yeah, distance divided by speed. So for the first half of journey, the time taken, that will be t1 will be how much? Distance divided by speed, that is x divided by v1. For the second half of journey, time taken t2 will be how much? Distance is again same, but speed is v2. So we got t1 and t2. So let me write a time t1 as x divided by v1 plus x divided by v2. So you have to solve this. X plus x is 2x. Okay. And in denominator, I can take common x. So 1 by v1 plus 1 divided by v2. Here I can cut 1x. Clear? So it will be 2 divided by 1 by v1 plus 1 by v2. I can write v1 plus v2 divided by v1 v2. So this v1 v2 part will come here. So finally, the average speed will be 2 v1 v2 divided by v1 plus v2. So I hope it's clear. Okay, this is how we calculate average speed. The equation of average speed is very simple. Total distance divided by total time interval. Average velocity will be total displacement upon total time taken. Clear? I hope it's clear. Let's move to question number 5. Application of Gauss law. Again, it's very important. Application of Gauss law is very important, very important. So basically, what is Gauss law? Gauss law is total electric flux over a closed surface enclosing a charge is equal to 1 enclosing a charge Q is equal to 1 by epsilon times the net charge enclosed. Okay. So yeah, basically it's saying electric flux over a closed surface. Suppose I have a charge Q here and a closed surface. This is the closed surface. So the total electric flux over a closed surface and enclosing a charge is equal to 1 by epsilon naught times the net charge enclosed. So here what will be the total electric flux? Total electric flux phi will be charge enclosed is Q. So Q times 1 by epsilon naught. Suppose if this is my Gaussian surface, this is my closed surface. Here flux will be how much? Total flux will be 1 by epsilon naught times into total charge enclosed. Here charge enclosed is 5Q. So it will be 5Q divided by epsilon naught. So mathematically, I can say Gauss's theorem is a flux phi equal to 1 by epsilon naught. 1 by epsilon naught into Q. Correct. Flux, we can also say that integral E dot ds. Yes, integral E dot ds is flux, or I can say integral E ds cos theta will be equal to Q divided by epsilon naught. This is what Gauss law. So the application of Gauss law, Gauss law, first we have to find electric field due to infinitely long, straight, uniformly charged wire. Okay. First application is field due to an infinitely long, straight, uniformly charged wire. Field due to an infinitely long, straight, uniformly charged wire. Yeah, this will be the diagram. This is the uniformly charged wire. Infinitely long, uniformly charged wire. It's positive charged. Uniformly charged, infinite long, straight wire. Yeah, the field due to this wire at a distance r from the wire. Will be the electric field will be at this point. Suppose C. At this point, C will be 1 divided by 2 pi epsilon naught lambda divided by R. Here lambda will be what? Linear charge density. Here lambda will be linear charge density. What is linear charge density? Charge divided by length. Clear? It will be electric field at this point C from a distance r from the wire will be 1 by 2 pi epsilon naught lambda divided by r. And if it is if the uniformly charged wire containing positive charge carries positive charge, electric field direction will be outwards, and it will, if the charge carries negative charge, electric field direction of electric field will be inwards. It's clear? Okay. And the second application is field due to a uniformly charged field due to uniformly charged infinite plane sheet. Field due to a uniformly charged infinite plane sheet. So suppose this is the plane sheet. Infinite plane sheet. Suppose it carries positive charge. So at a distance, any distance, electric field will be sigma divided by 2 epsilon naught. And electric field will be directed away from the plate if sigma is positive, and towards the plate if sigma is negative. Clear? See, from this equation we can make out one thing. There is no distance dependency of electric field due to uniformly charged infinite plane sheet. Whether it will be here, again sigma by 2 epsilon. If it is here, again to sigma by 2 epsilon. If it is here also, sigma by 2 epsilon naught. Clear? Where sigma is surface charge density. And it will be, sigma will be equal to charge contained divided by area. Clear? Yes. Next, third application of Gauss's law is field due to a uniformly charged thin spherical shell. Uniformly charged thin spherical shell. Okay, here we have to find in three cases. Okay, the first case is field outside the shell. Field outside the shell. Okay, field outside the shell. Suppose, this is the shell we have, and the shell carries a charge Q. Okay, this is the center of the shell. Have to find out electric field at outside the shell. Outside the shell, electric field will be how much? E will be, suppose this is the distance R. Okay, from the center of the shell. Okay, E at C will be 1 divided by 4 pi epsilon naught Q divided by R square. Okay, this is the field outside the shell. And the second scenario is field inside the shell. Field inside the shell. Okay, field inside the shell. Okay, this is the shell we have. Carries charge Q. You have to find out electric field inside the shell. Inside the shell, electric field is 0. Inside the shell, electric field will be 0. Inside the shell, electric field is 0. Clear? At the surface of shell will be, the distance R will be capital R, that is the radius of this shell. So the electric field will be 1 divided by 4 pi epsilon naught Q divided by capital R square. Clear? Yeah, the outside the shell will be 1 by 4 pi epsilon Q by small r square. Surface of the shell 1 by 4 pi epsilon Q by capital R square. Inside the shell, electric field will be 0. It's clear? Okay. Let's move to question number 6. What is kinetic energy? Again, very basic from work energy power chapter. Very, very basic question has been asked. What is kinetic energy? Yeah. So if we define kinetic energy, what is kinetic energy? Kinetic energy is the energy possessed by a body by virtue of its motion is called kinetic energy. Okay, what is kinetic energy? Kinetic energy is the energy possessed by a body by virtue of its motion. By virtue of its motion. If a body is moving, the body has to have a kinetic energy. Has to have a kinetic energy. And if a body is in rest, it won't have a kinetic energy. That's all. Energy possessed by a body by virtue of its motion is called kinetic energy. Kinetic energy. And we all know, if we all know the equation of kinetic energy is what? Kinetic energy, Ke, is equal to half mv square, where m is mass of the body and v is velocity of the body. Okay, if you want to derive that, how can we derive this? Okay, let me derive equation of kinetic energy. How it comes like half mv square. Okay, because the what is kinetic energy is a very simple question. Okay, it's nothing. It's nothing there. Okay, so let me explain what is kinetic energy. See, suppose consider a body of mass m. Okay, consider a body of mass m. Consider a body of mass m. Okay, which is initially at rest. That means its initial velocity is zero. Its initial velocity is zero, and I gave a force. So it got an acceleration, that is a, and its final velocity become v. Its final velocity become v, and it traveled a distance of s. So I can write a v square equal to u square plus 2s. From this equation, I can say v square equal to, here initial velocity is 0, so v square is equal to 2as. V square is equal to 2as. V square is equal to 2as. And s is equal to v square divided by 2a. Okay. And I have applied a force F here. So the work done will be how much? Work done due to that force. Work done due to that force will be, work done W is F dot S, that is Fs cos theta F dot S. So here it will be, F into S. So F into, okay, F I can write a mass into acceleration, correct? Ma into S is V square divided by 2A. So AA I can cut. So work done is equal to half mv square. And this work done, this actually the work done by the force, this work done actually appears as kinetic energy of body. This work done appears as this work appears as the kinetic energy of the body, as the kinetic energy of the body. And kinetic energy is equal to half mv square, where m is mass of the body and v is velocity of the body. It's clear? Okay. Let's move to question number. The next question is, it's a pretty interesting question and pretty important also. Why is the motion of a body moving with a constant speed around a circular path said to be accelerated? Okay, let me clarify that doubt. See, in a circular motion, we have two type of accelerations. Clear? One is centripetal acceleration and another one is radial acceleration. Okay. So I'm not going into types of acceleration, but simply the doubt is, okay, I have a circular path. Okay, I have a circular path. Okay. And this is the center of the circle. Okay. And the body is moving. And suppose this is the body. The body is moving with a constant speed. And this v, that speed is constant. But see, actually here, see, the magnitude of velocity may be constant, but see, direction is changing. No, see, if, okay, suppose body is here, at that time its direction of velocity is like this, and if the body is here, its direction of velocity is like this. The body is here, direction of velocity is like here. See, direction is changing. What is acceleration? Acceleration is rate of change of velocity. Okay, so velocity got two component, magnitude and direction. magnitude and direction. See here what's happening? Here magnitude is constant. Here magnitude is constant. Here magnitude is constant. Okay, here magnitude is constant. But see, direction is changing. But direction is changing, no? But direction is changing. So the direction is changing, velocity is changing. Velocity is changing. The body has to be an acceleration. The body is an accelerated motion. Okay. So basically, this is explanation. Although the speed of a body moving in a circular path may remain constant, speed remain constant. Speed means magnitude of velocity. Its direction changes continuously. Correct? I have shown you. Acceleration in physics isn't just about changing speed. Clear? Also includes change in direction. In circular motion, there is a centripetal acceleration directed towards center of the circle, responsible for keeping the body in curved path. It's clear? Okay. Let's move to next question. Next question is law of equipartition of energy. It's from thermal properties of matter. Again, it's very important, very important. Okay, this law of equipartition of energy and degrees of freedom and all, CV, CP, gamma and all is very important. So basically, what is law of equipartition energy? The law of equipartition of energy states that if a system is in equilibrium at absolute temperature T, basically the temperature of the system is T, the total energy is distributed equally in different degrees of freedom. The energy each degree of freedom being equal to half kBT. That means each degree of freedom will have a kinetic energy of half kBT. If suppose there is F degree of freedom, Suppose if there is F degree of freedom, then the total energy will be how much? F into half kBT, where kB is Boltzmann constant, T is temperature. Okay, basically law of equipartition of energy is saying that, energy is equally shared to every degrees of freedom. And what is equally shared? The amount of equally shared is half kBT. That means energy is equally shared to each degree of freedom as half kBT. Like half kBT, half kBT, half kBT. If suppose 3 degrees of freedom exist, and the energy will be 3 into half kBT. It's clear? That is what law of equipartition of energy. This is what law of equipartition of energy. I hope it's clear. Okay, and see, let me add some extra point. Let me set up some extra point. See, for monoatomic molecule, everyone know for monoatomic molecule. What is the degree of freedom? 3. Correct. Degree of freedom is 3. For monoatomic molecule, degree of freedom is 3. So total internal energy of the molecule will be how much? Total energy will be 3 into half kBT. Each degree of freedom go to half kBT. And monoatomic molecule has 3 degree of freedom. So total energy will be 3 into half kBT. That is 3 by 2 kBT. And next scenario is a diatomic molecule. Actually, I have taken thermal properties of matter class, including exercise solution and a theory explanation. It will be available in YouTube channel, so you can please check out that. Okay, I have explained very well in that videos. Okay, this is diatomic molecule. Diatomic molecule, we have 2 types, and its degree of freedom is, suppose if it is 5, that is rigid support. If the diatomic molecule having rigid support, okay, this is for diatomic rigid rotator. Diatomic rigid rotator, degree of freedom will be 5. And diatomic molecule, degree of freedom will be 7 if it is a non-rigid rotator. If it is a non-rigid rotator, Clear? So diatomic molecule, if it is a rigid rotator, degree of freedom is 5, and it is a diatom. If it is a diatomic non-rigid rotator, degree of freedom will be 7. Okay, if degree of freedom will be 5, total energy will be how much? 5 into half kBt. That is 5 by 2 kBt. And for diatomic non-rigid rotator, degree of freedom is 7. So total energy will be 7 into half kBt. It will be 7 by 2 kBt. Clear? Clear? Yes. Okay, this is what law of equipartition of energy. Okay, let me move to question. The next question. Next question is, what is net force? Okay, what is net force? They say, oh, net force. So net force, like force is a vector quantity. So net force, it will be vector addition. And also, actually, I have brought to a question for you. So let me solve that question. It will be clear for everybody. Okay, net force. So see, I have two force here. I have, okay, this is my body. Okay, this is my body. Okay, I have taken a body here. Okay, clear. Okay, this is my body. And two forces have been applied. Okay, it is lying in a ground. It is lying in a ground. And two forces have been applied into the body. The first force is, this is horizontally 80 Newton. Second force is, this is what? 60 Newton. This is 60 Newton. And the angle between these is 60 degree. What is a net force? Here I have to find out what is a net force. What will be the net force? What will be the net force? What will be the net force? Okay, so if I want to solve this problem, I have to know parallelogram law of vector addition. Clear? So by parallelogram law of vector addition, by parallelogram law of vector addition, by parallelogram law of vector addition, parallelogram law of vector addition. Basically, it is saying what? Yeah, same scenario only. I have a vector A here, I have a vector B here, and it is separated by angle theta, So the resultant vector R will be, its magnitude will be root of A square plus B square plus 2AB cos theta, and its direction will be tan alpha is equal to, and its direction will be, okay, just let me find the magnitude. Magnitude R will be, resultant will be root of A square plus B square plus 2AB cos theta. Root of A square plus B square plus 2AB cos theta. Okay, see, in this question, so the resultant force or the net force will be root of 80 square plus 60 square plus 2AB cos theta, correct? 2 into 80 into 60 into cos 60. Clear? Okay. And it will be root of 80 square will be how much? 6,400. No. Yes. Plus 60 square will be 3,600 plus 2 into 80 into 60. 2 into 8, 16. 16 into 6. 16 into 6 will be how much? 96. 96, 0 into what is cos 60? Cos 60 is 1 by 2. And if I solve this, I will get the answer. Clear? Okay. This is how we calculate the net force. Okay. By using vector addition, like parallelogram law, vector addition and all. Clear? Root of A square plus B square plus 2AB cos theta. Clear? Yes. Okay, moving to next. The next question is, oh, what is the difference between latent heat of fusion and latent, okay, I have got it. Latent heat of fusion and latent heat of vaporization. Okay, this is the question I have been asked. Latent heat of fusion versus latent heat of vaporization, what is the difference? Okay, basically, See, it's again from thermal properties of matter. Okay, that chapter I have discussed already in YouTube. It's there in YouTube. You can go and watch that. I have beautifully explained the chapter. Okay. See, what is melting? Okay, okay, let me explain some basic things here. What is melting? What is melting? Melting is yeah, it's the transformation from solid to liquid. That is melting. That is ice to water. That is actually melting. Okay. What is fusion? What is mean by fusion? Fusion is it's a transformation from liquid to solid. That is, pani becomes ice. That is fusion. Okay. Now what is melting point? Temperature at which solid is converted to liquid is melting point. Okay, so melting and fusion is clear. No, melting is transformation from solid to liquid, and fusion is transformation from liquid to solid. And what is latent heat of fusion? It is the amount of see. What is fusion? It's a transformation from liquid to solid. Clear. So what will be the latent heat of fusion? It is the amount of heat required to convert 1 kilogram solid substance completely into liquid. Completely into liquid. Completely into liquid at its melting point without any change in temperature. This is what latent heat of fusion. This is what latent. This is what latent heat of fusion. That is, I have 1 kilogram solid substance. I have 1 kilogram solid substance. 1 kilogram solid substance. Okay, I have to change this into liquid. I have to change this into liquid. So here the amount of energy, amount of heat required to convert 1 kilogram solid substance completely into liquid at its melting point without any change in temperature. There shouldn't be a change in temperature. That is called latent heat of fusion. So the amount of heat I have to given will be how much LF, that is latent heat of fusion. And latent heat of fusion is given by, okay, latent heat, no, here the heat given by Q, which is equal to M into LF, where LF is latent heat of fusion. Latent heat of fusion times mass will be the heat required. Okay. The next, what is latent heat of vaporization? Again, same concept. It is the amount of heat required to convert 1 kilogram liquid substance completely into gas at its boiling point without any change in temperature. So here, okay, latent heat of vaporization, what's happening? I have a 1 kilogram liquid substance. I have 1 kilogram liquid substance. I have 1 kilogram liquid substance. Okay, I have 1 kilogram liquid substance. I have to convert this into gas. I have to convert this into gas. Suppose, okay, I'm depicting this as gas. So the amount of heat required to convert 1 kilogram liquid substance completely into gas at its boiling point without any change in the temperature is called latent heat of vaporization. So the amount of energy required here will be how much? Amount of energy required will be mass into LV, where LV is latent heat of vaporization. LV is latent heat of vaporization and LF is latent heat of fusion. So latent heat of fusion is amount of heat required to convert from solid to liquid. And what is latent heat of vaporization? It's the amount of heat required to convert from liquid to gas. See, if we put M as 1 kilogram, the heat will be LF, heat will be LV. Suppose, okay, it's clear now? Correct. So Q will be MLF and Q will be MLB here. Okay, yes. Okay, let's move to next question. Okay, next question have been asked is, what is quantization of charge? Okay, it's been again I have taken chapter electric charge and field. It's again in YouTube, you can go and watch. So I have explained it's the property of electric charge. The property of electric charge is quantization. One of the property of electric charge is quantization. What is mean by quantization of electric charge? According to quantization of electric charge, in the universe, charge of any body is an integer multiple of E. That means in the universe, okay, charge of any body, Okay, anybody, you take anybody. Okay, suppose charge will be integer multiple of E. That means total charge of anybody will be n times E, where n is an integer, and E will be, yeah, charge of electron, that is 1.6 into 10 raised to minus 19 coulomb. That is like charges like 1E, 2E, 3E are possible, but a charge like 1.5 is not possible. That means a body can have a charge 1E, a body can have charge 1E, 2E, 10E, 10 lakh E, 1 crore E, but not 2.5. This is not possible. 3.5 not possible. Okay, 10.5 not possible. This is what basically quantization of charge says. That means charge is quantized. Charge will be an integer multiple of E, where E is charge of electron, that is E is equal to 1.6 into 10 raised to minus 19 coulomb. Clear? Okay, again, let me tell you again, quantization of charge means a charge can't be like 1.5 E, 2.5 E, like half E. Clear? Clear? It will be an integer multiple of from like minus, it can be minus, it can be positive, it can be zero, but not like 1.5, 2.5 and all. Clear? Okay, so quantization of charge is done. Okay. Next question is, what is an electric dipole? What is an electric dipole? Again, I have taken this lecture in the chapter electric charge and field. It's given in YouTube. You can check what is an electric dipole. What is an electric dipole? It's very basic, simple thing. Two equal and opposite charges separated by a small distance is called an electric dipole. Okay, suppose I have two charges. Same in magnitude, but opposite in charges and separated by a small distance. Small distance. That is, here I'm taking 2A. This is an electric dipole. What is electric dipole? Electric dipole is two equal and opposite charges separated by a small distance is called an electric dipole. So what is electric dipole? Two equal and opposite charges separated by a small distance is called an electric dipole. Okay, let me add one point also. What is electric dipole moment? Electric dipole moment is defined as the product of magnitude of one of the charges and length of the dipole. So electric dipole moment is a vector that will be one of the charges into separation between the charges. That is here 2A. P into P is equal to Q into 2A. Clear? Here what is P? P is dipole moment. Electric dipole moment. Electric dipole moment. Okay. And its electric dipole moment is a vector quantity. Electric dipole moment is a vector quantity. Clear? Okay. Next question is, how heat transfer? Okay. Again, it's from thermal properties of matter. We have three distinct modes of heat transfer. Clear? We have three distinct modes of heat transfer. What are they? Conduction, convection, radiation. Conduction, convection, radiation. Okay. From conduction, what is conduction? Conduction is the transfer of heat between two adjacent parts of a body because of their temperature difference. Difference. See, okay, let me take an example here. Okay, here TH means temperature of hot reservoir. Here TH means temperature of hot reservoir. Here TH means temperature of hot reservoir. And what is TC means? TC means temperature of cold reservoir. Temperature of cold reservoir. Okay, so see, what is conduction? Conduction is the transfer of heat between two adjacent parts of a body because of their temperature difference. There should be temperature difference. See, it is hot. Here it is hot. Here it is cold. So temperature difference is there. So transfer of heat will happen from hot to cold. So this will be the direction of heat transfer. Clear? Okay. And we can make out the equation of rate of flow of heat. Rate of excuse me. So see, rate of flow of heat. Okay, it's given by capital letter H, rate of flow of heat. Rate of flow of heat H. Rate of flow of heat H. It is directly proportional to okay, that rate of flow of heat is given by capital. It is given by the equation K A T H minus Tc divided by L. Okay, what is K here? Here K is thermal conductivity of the material. Here K is thermal conductivity of the material. Here K is thermal conductivity of the material. Here K is thermal conductivity of material. And what is A? A is area of cross section. Area of cross section. What is L? L is length. The material. And what is TH minus TC? So difference between temperature of the hot reservoir and temperature of the cold reservoir. So rate of flow of heat H is equal to Ka TH minus TC divided by L. Clear? I hope it's clear. Okay, let's move to next question. What is vector and what is scalar quantity? Again, it's very basic from motion in a plane chapter. Yeah. What is scalar and what is vector? Okay, let me explain that. What is scalar and what is vector? What is scalar quantity? What is mean by scalar quantity? What is mean by scalar quantity? Scalar quantities are actually the physical quantities. The physical quantities which have only magnitude, is scalar quantity. For example, mass, time, pressure, and all. Physical quantities which have only magnitude is scalar quantity. What is vector quantity? What is vector quantity means? Vector quantity means okay, it will which okay vector quantity have both direction and magnitude. Vector will be having both direction and magnitude. Both direction and magnitude. And they obey the laws of vector addition. And they obey the laws of vector addition. Example പറയാൻ പറഞ്ഞാൽ വെക്ടറിന്റെ എക്സാമ്പിൾ പറയാൻ പറഞ്ഞാൽ ഒന്നാമത്തെ നമുക്ക് എന്താ പറയാം ഡിസ്പ്ലേസ് see okay have both direction and magnitude and they obey the laws of vector addition. Example will be displacement velocity. Example will be displacement velocity. This velocity, acceleration, force, momentum, angular displacement, angular velocity. Okay, we will n number of examples for vector. Vector is having both direction and magnitude. Scalar is having only magnitude. Okay, let's move to next question. What is universal laws of motion? Again, yeah, basic from motion, laws of motion chapter. Okay, we have 3 laws of motion: Newton first law, Newton second law, Newton third law. What is Newton first law says? Yeah, Newton first law. First law says, I'm not writing. First law says every body continues in its state of rest or of uniform motion in a straight line unless compelled by some external unbalanced force to change the state. So basically we have got momentum from Newton's first law of motion, that is momentum P is equal to m into v, mass into velocity. Again, second law. What is second law says? Second law says Newton's second law states that the rate of change of momentum of a body is directly proportional to the applied force, and the change in momentum takes place in the direction of force. Basically, second law says force is directly proportional to rate of change of momentum. And from this, we have got the equation force is equal to mass into acceleration. How did I get? Force is directly proportional to dp by dt, that is the rate of change of momentum. Second rate f is equal to some constant k into dp by dt, and here k is 1, so I can write f is equal to dp by dt. F is equal to d by dt of p. I can write mass into velocity. Mass is a constant. Let me take mass outside, d by dt of velocity. What is dv by dt? That is acceleration. So f is equal to m into a. Clear? So this is Newton's second law. What is Newton's third law? Then third law is, what is Newton's third law? Okay, let's move to Newton's third law. Third law is for every action, to every action, there is an equal and opposite reaction. Should I write that? I don't think I should write that. Oh, to every action, it all given in NCRT. To every action, there is an equal and opposite reaction. There is an equal and opposite reaction. To every action, there is an equal and opposite reaction. Clear? Okay. Let's move to last question have been asked is VT and DT graph. VT and DT graph. Okay. This is again very important. It can come in MCQs. It can come in NEET. Okay. Well, also first is let me explain about velocity time graph. Velocity time graph. Velocity time graph. Suppose there is no acceleration. First condition is there is no acceleration. So velocity time graph will be like this. Velocity is constant. See, time is changing, but velocity is not changing. Why? Acceleration is zero. Acceleration is zero means dv by dt is zero. dv by dt is zero means dv is zero. dv is zero means change in velocity is zero. Change in velocity zero means velocity is constant. Velocity is constant. So velocity is constant, not change. This is the first condition. Okay. Second condition is if the acceleration is constant. The acceleration is constant, VT graph. This is VT graph. If the acceleration is constant, graph will be like this. See, what will be the slope of VT graph? Slope will be V by T. That is acceleration. Acceleration is constant, so slope is here constant. Clear? Okay. Yes. And third scenario is increasing acceleration. Acceleration is increasing. That is the case. Acceleration is increasing. That is the case. This is here V, here T. If acceleration is increasing, the slope should increase. So like this. Okay. Slope will be acceleration. So slope of velocity time graph is acceleration. So here acceleration and slope is also increasing. Hence acceleration is also increasing. Okay. Next, what is DT graph? What is DT graph? What is DT graph means? Distance time graph. Distance time graph. Or displacement time graph. Okay, here I am taking distance time graph. Okay. First scenario here is stationary body. For a stationary body, distance time graph. This is the distance d. I'm taking d, and here is ti. For a stationary body means it is not moving. So its distance should be constant. So it will be this will be the graph. Okay, clear? Yes. And second condition is for uniform motion. Uniform motion means velocity is constant. For that, graph will be distance at time. Velocity is constant. So slope will be constant. Okay. Actually, what is the slope of a distance time graph? Velocity. Okay. And for non-uniform motion, it will be like this. For non-uniform motion, it will be like this. Okay, I'm stopping here because I have to share some tips. Okay. So see. Okay. Physics. Okay, I can categorize physics as how see mechanics. Mechanics include motion in a straight line, motion in a straight line, motion in a straight line, motion in a plane, loss of motion, work energy, power, up to rotational motion, up to gravitation. Okay, this is mechanics. See, mechanics, if we know the concept in mechanics, it will be very easy in it. Okay, mechanics is a portion like we can easily solve if we know every equation. Okay, next is electromagnetism. Electromagnetism. From electromagnetism, we have, again, it's a very important portion. Electromagnetism, we have electric charge and field. Okay, electric charge and field. Electric potential and capacitance. Current, electricity, moving charge and then magnetism and matter, electromagnetic induction, AC. Correct. So those chapters from plus two physics, that's also very boring. So if you spend more time in electromagnetism, you are just starting now, you have to spend more time in electromagnetism, those portion and mechanics first. First finish this. That's basically the first part of plus one physics and the first part of plus two physics. Okay, first finish this and then come back to chapters like mechanical properties of solid, mechanical properties of fluid. These all are now we can easily complete, we can easily revise, we can easily solve questions. Actually, in mechanics and electromagnetism, the concept should be clear. So spend more time in mechanics and electricity and magnetism. Okay, then come to chapters like motion, mechanical properties of solid, mechanical properties of fluids, thermodynamic, thermal properties of matter, kinetic theory of gases. Okay, and after that, before that, you have to see oscillation and wave also. These chapters also has some concepts. So if the oscillation is comparatively easy, wave is somewhat difficult. Okay, but not that much difficult. But if oscillation is clear, okay, wave will be also easy. Okay. So, and the fourth portion is ray optics, wave optics, optics. Basically saying optics. Basically, I would say optics. So, see, you have to do is first solve or first complete or first revise these portions. First mechanics, then go to electromagnetism, and then go to optics, then go to oscillational wave. First conceptualize, first clarify all the concept, all the equations, all the derivations and all, and solve all previous year questions from mechanics first, electromagnetism, optics, and the oscillation and wave. Clear? Once it is done, make small notes of equation from mechanics, electromagnetism, oscillation, and wave optics. Okay. Once it is done, then go to chapters like mechanical properties of fluids, like mechanical properties of matter, basically solid, fluid, heat, and all. Then go there. Then after that, dual nature of matter, photoelectric effect, and all. Okay. So I would say first complete these chapters: mechanics, electricity and magnetism, oscillation and wave, optics. Okay. I hope today's session is useful for you. Have those questions I have shared, I have solved everything. Okay. These questions were very basic, nothing complicated and all. So all the best for your future exams. And Sati is doing great work for students. Okay. So yeah. So let me conclude here. So all the best for your exams. Okay. Study well, prepare well. Okay. Thank you, guys.